It is areas of triangles next in our list. Now this is probably a lot of review for you here. Area triangle is a basic one. The formula, as you probably already know, is to take half of your base times the height. But I still want to show you why that is. So I've drawn a parallelogram here for you, and I've shaded in the triangle, and I'd just like to convince you that that triangle that's shaded is exactly the same or congruent as the one that's not shaded. It's not too hard to prove that since it's a parallelogram. I know my opposite sides are congruent, both pair. And then the diagonal acts as a shared side between those. So this is a simple side congruence of triangles. But the area of that parallelogram is, again, from our last lesson, it's the base across multiplied by the height of the parallelogram measured at a right angle. Well, that's the same as the base of the triangle and the height of the triangle. So I'm just cutting it in half because it's half of the parallelogram. Pretty simple. Let's go put it on your formula master sheet. The formula for the triangle is area equals half the base times the height. So 1/2 base times height. But the tricky part is sometimes it's hard to identify the base and the height of a triangle. So I've given you 3 examples. Now if you just have your basic triangle, yeah, you can use the side across the bottom to be your base, and then just coming from the point straight down, use that as your height. Just be sure you have the right angle. That's the most important part. If you have a right triangle, however, you already have a right angle supplied for you. So in a right triangle, you can use the 2 legs as your base and your height. And that's kind of convenient a lot of the time. And then on a triangle like this, if you still want to stick with the base being the bottom, you can have a little bit of a challenge. You can do it, but just understand that the height is going to be straight on down, and you might not be able to hit the base because it's way over here, but you would make a right angle. So in a lot of pictures, you will see just this, or sometimes you'll see a little dotted line showing the extension of that out to make the perpendicular lines. That's the height right there. But it's important to remember that your base is still just this side of the triangle, even though your height's going to be measured out here. And I'd like to do it like I did before and highlight our base and our height in our formulas, just so there's no confusion. All right, let's check out some examples with these formulas. Here's your basic geometry kind of question. Find the area and the perimeter of this triangle. So I'm noticing that I do have a right triangle, and that means that I can use my base across the bottom and my height as the other side, the 2 legs. I'm also noticing that this is a 30-degree angle. How am I going to use that? Well, it's a 30, 60, 90 triangle. So I'm going to be able to use my special right triangle relationships. If I want to come to this side from that 12 centimeters, I'm just timesing by radical 3. So this side's going to be 12 radical 3. And might as well do it while we're here. Going to the hypotenuse is just a matter of doubling that 12, so this is going to be 24. Of course, these are centimeters. All right, so let's do the area. The area is, remember, the half. It's important to remember that half on our formula. Half our base times our height. So if I'm looking at this picture, I'm going to use that bottom side as my base. That's the 12 radical 3. And then the height, since they made a right angle, is my 12 centimeters. And so as I calculate this, let's just take half of 12, or 6, and 6 times 12, everything not in radicals multiplied together. That gives me 72, and I'll just bring down my radical 3. And then, of course, my units are still square units here, so square centimeters. And this would be my answer if I'm looking for an exact answer. But if I want to go into decimal, let's just put both answers down. So the decimal value for that, multiplying the 72 by radical 3, is going to give me about 124.7 if I'm rounding to the tenths. Okay, so let's box them both. One's an exact answer, one's our approximation. I like them both. Okay, before we leave this, let's do the perimeter by adding all 3 sides up. Starting with the bottom, I've got 12 radical 3, and then working my way around, I'm going to add the 12 and the 24 for all 3 sides together. And just like we saw in the last lesson, you cannot add that radical to these others without first going into decimal. So let me just take the 12 and 24 and combine those into a 36 and bring down the 12 radical 3. And this would be in centimeters. That's my exact answer. If I want to go into decimal, I have to change this 12 radical 3 first. So multiplying those together, it's about 20.7, and then I add the 36. Now I can combine them for an approximate 53.7 centimeters. So there's my approximate answer, and then here's my exact answer, just leaving it in the radical form. Okay, this one we're going to work backwards. Anytime you know the area, they're probably asking you for one of the dimensions, and that's the case here. So let's write our formula down. It is still a triangle, half the base times the height. And just making substitutions, the area here is 350. And then 1/2, I don't know the base, so I'll just call that base, B. But I do know the height is 14. So just a little cleanup over here. What's half of 14? I'm going to just say that's 7 times the base. Okay, bringing everything down, I'm just going to divide by 7. You guys know how to do this. So it looks like 50 is my base length, and that is a length. It's 50 feet from the units of the problem. The base would be 50 feet. My favorite kind of problems. This is a real-life example. You do this kind of stuff all the time if you own a house. So if you ever plan on living in a house, know how to do this. We are going to paint the front of a shed. And note that 1 can of paint covers 20 square feet. We'll come back to that in a minute. We are not painting the 6-foot square door. So how much paint do we need for this? Well, we're going to have to break this into pieces. It's already been done for us. It looks like we have a triangle roof. And so I'm going to kind of make a plan here. I'm going to take the triangle roof area, and then we're also going to paint the rectangle on the base. So I'm going to add that to it, but we're not painting the door. So let's subtract out the square area for the door and just break this into pieces and parts. Okay, I think the triangle is going to be the trickiest part, so let's do that first. I am going to take 12 feet as my base. I'm going to take 12 feet as my base, and we'll use the height right here from the peak straight down, hitting, of course, at a right angle. Now notice that this was isosceles, so when I draw in this height, I did a nice bisecting split. So that 90-degree angle just got bisected into a 45-degree angle on each side. And knowing this is a right angle here, this gives me a nice 45, 45, 90 triangle. So let's just say that this piece of that triangle is 6, and that means this other side is matching 6. So I have a 6 and a 6 on each side, and this of course would be 6 radical 2. Alright, so my area for the triangle is half of the base times the height. Now looking at this triangle, remember I'm doing the whole roof. The whole base across is 12, and then the height down is 6. So I'm going to use 12 and 6 in there. That's going to give me a total area of 36. So 36 is my triangle area. Now let's do the rectangle. How far across the rectangle? Well, that's 12. It's a 12 by 8 rectangle. 12 by 8, so 96 is the area of my rectangle. And then on my square, remember it is a square, so it's 6 by 6. So 6 by 6 on the square is going to give me 36 for the area I'm going to subtract out, not painting that door. All right, let's combine it up. So 30, oh, check it out, guys. I get to cancel these 36s. That's nice and easy. So we just have a 96 square foot area that we need to cover with paint. All right, so how much paint do we need? Each can is going to cover 20 square feet. So let's take our total and divide it by the 20 square feet that each can will do. And dividing that out gives me 4.8 cans of paint that I need. All right, so that's my answer. Now, of course, I'm going to go buy 5 cans because they're probably not going to sell me a piece of a can. Cool. Love these triangles.